separation of variable method. What is this? Let me discuss the fundamental of this topic. If a differential equation can be written in the form fy dy is equal to yx dx. That means all the values contained y will remain in the left hand side and other values will remain in the right hand side. We say that the variables are separable comma y on left hand side and x on right hand side. And we get our solution by integrating both sides. Okay, so let's start with a question. Solve x plus 1 dy upon dx equals x y square plus 1. So what we have to do in this one, first we write our equation in this way: dy upon dx is equal to x y square plus 1 upon x plus 1. Remember one thing, that dy and dx will never in denominator. This implies that 1 upon y square plus 1 into dy is equal to x upon x plus 1 into dx. So what happened in this equation, you can see that each value of y is in the left hand side and x is in the right hand side. Now just integrate this, integrating both sides. So this implies that integration of 1 upon 1 plus y square dy is equal to integration of x upon x plus 1 into dx, plus you have to put one integrating constant. Integrating constant you can select as per your choice. Okay, but remember, if each and every part of the solution is in the terms of log, then try to consider the integration as a log. So this is the integration of tan inverse y. You cannot integrate it directly, so break it like that one: x plus 1 minus 1 we add 1 and we subtract 1 dx plus constant c. This implies that tan inverse y is equal to integration of x plus 1 upon x plus 1 minus 1 upon x plus 1, and then you have a dx plus constant c. This implies that tan inverse y is equal to integration of this will cancel, so what you have only dx, and then minus integration of 1 upon x plus 1 dx plus constant c. This implies that tan inverse y is equal to x minus log 1 plus x plus constant c. So this is your final answer for this question. Let us consider another question. Question number 2. What's the question? See, solve d upon dx plus tan y dy equals to 0. So in this question there is no specialty, variables are already separated, so you can solve it very easily. So let's see. Solution. Given dx upon x plus tan y dy is equal to 0. This implies that integration of dx upon x plus integration of tan y dy is equal to log c. Intentionally I am considering this log c, because when you integrate the both parts of left hand side you get the answer in the log. This implies the integration of the first part, again I am writing the part dx upon x plus integration of tan y dy is equal to log c. This implies that log x plus log, you will get here sec y is equal to log sec c. This implies that log x into sec y is equal to log c. Now log will cancel, so your final answer is x log sec y is equal to c. I think now it's clear for all of you. Okay, and this question can be asked in another form, and let's discuss another question. Question number 3. Solve dy upon dx equals under root 1 minus y square upon under root 1 minus x square. Solution. Given dy upon dx to under root 1 minus y square upon under root 1 minus x square. Again we have to separate the variable. Then what happened? You have our dy in denominator. Just consider 1 minus y square is equal to dx on under root 1 minus x square. This implies that now the variables are separated, so we will integrate both sides. Integrating both sides. So what do you have? Integration of dx upon under root 1 minus x square equals to integration of dy upon under root 1 minus y square plus constant c. So what's your answer? You have the answer sine inverse x is equal to sine inverse y plus constant c. And always remember one thing, try to keep the y variable in the left hand side. So its another answer is, if you write like that one, dy under root 1 minus y square is equal to integration of dx upon under root 1 minus x square plus constant c. This implies that sine inverse y equals to sine inverse. Both answers are correct, but always try to keep y in the left hand side. So this is the questions you have to understand. Now let's see few more questions which will help you to get the solution of the equations. So another question. I think this is question number 4, no? Question number 4. Solve dy upon dx equals x 2 log x plus 1 upon sine y plus y cos y. So let's see the solution. Given dy upon dx equals x 2 log x plus 1 upon sine y plus y cos y. This implies that you have sine, separate the variable, cos y. Each term of y will in the left hand side as well as each term of right hand side in the x in the right hand side into dx. Now proceed on the next page. So this implies that open all the bracket, sine y into dy plus y cos y into dy equals to x. Just see the back. 2x log x dx plus x dx. Integrating both sides. Integrate integrating both sides. So what you will get, just see here, this implies that integration of sine y dy plus integration of y cos y dy equals to integration of 2x log x dx plus integration of x dx plus constant c. This implies that we all know the integration of sine y is minus cos y. Now here we have to apply the first and second principle by Euler rule, assume it. So you have a formula, first into integration of second cos y dy, put a bracket here, minus integration differential of first function into integration of second function, that means cos y, and after then again integration of this part dy. So this is your answer. Here you have a 2. I am not going to integrate it right now. Log x dx, and this gives you a x square by 2 plus c. This implies that minus cos y plus y, the answer of this is sine y, minus the differential of y is 1, so this is the integration, the differential, this is 1, so I am not going to write 1. You will get the integration of cos y as a sine y dy. Again you have to apply first and second concept here, but what you have to do, you just consider log x as first function. So log x is your first function and this is your second function. So let's see what happened. 2 times in bracket first function log x integration of second function minus integration of differential of first function log x into integration of second function dx, and after then integration of whole part. Okay, so and then close this bracket. Now plus x square by 2 plus c. This implies that minus cos y and plus y sine y, you will get the integration from this segment minus plus cos y, because the integration of sine y is cos y. You have a 2 and this gives you x square by 2, so you have a x square by 2 log x remains x. Now check another part, what we will get from here, minus you will get keep this bracket, you will get the differentiation of log x is 1 by x, the integration of second part x square by 2 whole integration, close this bracket, plus x square by 2 plus constant c. This cos y will cancel. Now u remains y sine y equals to, I'm not going to open the bracket right now, x square by 2 log x, this x will cancel, so you have a minus, and the integration of minus 1 by 2 x square by 2. Now close this bracket, plus x square by 2 plus constant c. So I am just going to copy this in the next page and then we will solve. This implies that y sin y equals to 2 times x square by 2 log x. See another part, log x minus x square by 4 bracket close plus x square by 2 plus constant c. Now open all the brackets. So y sin y is equal to x square log x minus x square by 2 plus x square by 2 plus constant c. This and this will cancel. So you have y sin y equal to x square log x plus constant c. This is your final answer. So till now we see the 4 questions. Now we are going to discuss few more questions. So this will clear all your concepts of the separation of variable. Question number 5. What is the question? Solve x dy upon dx plus cot y is equal to 0 given y is equal to pi by 4 where x equals to root 2. So what happened in this question, one specialty is there. Some values of y and x are given. So why these values are given? When these type of values are provided, you can find the constant. Okay, I will show in the solution part, so be careful. Given x dy upon dx, if you see the question number 1, not 1, sorry, the question number 2, this is very identical as the question number 2. This implies that x dy upon dx is equal to minus cot y. This implies that you just write it like that one. See, x dy upon dx is equal to minus 1 upon tan y. I am just breaking it. This implies that tan y dy is equal to minus dx upon x. You can keep this in the left hand side, so, or you can also keep it in the right hand side, no issue. Okay, so integrating both sides. So you see each and every term you will get in the terms of log. So we will consider our tan y dy, sorry, not dx, dy is equal to minus integration of dx. We will consider our constant as log. You have to imagine one step forward. The answer of this is log sec y. This is minus log x plus log c. Try to remove this minus sign. So what you have, a log sec y is equal to log x inverse plus log, sorry, plus log c log c. This implies that log sec y is equal to log 1 by x plus log c. This implies that log sec y is equal to log c upon x. Now the log will remove, so what you have, a sec y is equal to c upon x, so finally what you have, this implies that you have x sec y is equal to c. This is your answer, but in this question the conditions are provided. What are the conditions? See, y is equal to pi by 4, y is equal to pi by 4, and x is equal to root 2. So when you are going to put, okay, so when you are going to put the value of sine this, you have a root 2 into sec pi by 4 is equal to c. This implies that root 2 into the value of sec pi by 4 is 1 upon root 2 is equal to c. So this implies that 1 is equal to c, that is c is equal to 1. Put this value in your equation number 1. So x sec y is equal to 1 is the final answer. So